Hello, hello. So we're going to go ahead and start off with a recap of the first two trig derivatives that we learned, which is the derivative of sine is equal to cosine, and the derivative of cosine is equal to negative sine. Using those, we're going to go ahead and practice finding the derivative of different types of functions, just so we can see how it goes. So the first one I give is y equals 2 sine of x minus cosine of x. This is a simple power rule. Derivative of sine is cosine, so this becomes 2 cosine of x minus a negative sine of x, because that's what the derivative of cosine is. Double negative becomes positive. On the next one, I have y equals x times sine of x. This is clearly a product rule function. So my derivative is going to equal the derivative of the first function times the original second function plus the original first function times the derivative of the second function. So I get 1 times sine of x plus x times cosine of x. From here, I can just go ahead and simplify. I get sine x plus x cosine of x. And that's it. Example number 3 is going to be a quotient rule problem. So I start with the derivative of the numerator, which is negative sine of x, times the original denominator, minus the original numerator, times the derivative of the denominator. Derivative of 1 is 0. Derivative of sine is cosine. All over that denominator squared. From here, I can just go ahead and simplify. And when I do, I distribute the negative sign. So I get negative sine x minus sine squared x, because sine times sine is sine squared, minus cosine squared x, all over 1 plus 2 sine of x plus sine squared x. From here, I could go ahead and recognize that sine squared x and cosine squared x, when they're added together, are a Pythagorean identity. So what I'm going to do to make that true, which will allow me to reduce it, I'm going to go ahead and pull a negative out of both of those terms, which makes the inside addition. Sine squared x plus cosine squared x is equal to 1 in that Pythagorean identity, which means this simplifies into negative sine x minus 1 over 1 plus 2 sine of x plus sine squared of x. Okay? Now that we've practiced sine and cosine, we can go ahead and take a look at our other trig derivatives. Okay, so there are 4 more. The derivative of tangent is secant squared x. The derivative of cotangent is negative cosecant squared x. The derivative of cosecant x is negative cosecant x cotangent x. And the derivative of secant is secant x tangent x. So we're going to go ahead and use those to practice some more derivative problems. The first one I'm looking at here is y equals 3x plus x tangent of x. This part's going to be power rule. This part's going to be product rule. So I start by just taking the derivative of my power rule part. Derivative of 3x is just 3, plus, here's where I'm going to have to do my product rule. Derivative of the first term is 1 times the original second term, plus the original first term, times the derivative of my second term, from here I can just go ahead and simplify. I get 3 plus tangent x plus x secant squared x, and that's it. Next problem is going to be a quotient rule problem. So I have y equals 1 minus sine of x over 1 plus sine of x. So I'm going to go ahead and start my derivative. I take the derivative of the numerator. Derivative of 1 is 0. Derivative of negative sine is negative cosine, times my original denominator minus my original numerator times the derivative of my denominator, all over that denominator squared. So I'll square that out later. I'm just going to write it for now. Okay, so what I'm going to do from here is I'm going to simplify that numerator. So I get negative cosine of x minus cosine x sine x minus 1 plus sine x cosine x, because a negative times a negative. Then I can go ahead and combine like terms. The really cool thing is this and this are the exact same, so they cancel each other out since one is positive and one is negative. So I'm just left, don't forget about our denominator. So in my numerator, I'm just left with negative cosine x minus 1 over, and then I can go ahead and FOIL out my denominator, which is 1 plus 2 sine of x plus sine squared of x. My next problem then is y equals sine of x times cosine of x. Again, this is product rule. Derivative of sine is cosine times my original second, which is cosine, plus my original first, which is sine, times the derivative of cosine, which is negative sine. Simplify. And I get cosine squared x minus sine squared x. Because cosine times cosine is cosine squared. Sine times a negative sine is negative sine squared. Next one, secant x plus cosecant x. The good news is this one's just a power rule. So y prime is going to be equal to the derivative of secant, which is secant x tangent x, plus the derivative of cosecant, which is negative cosecant x cotangent x. I go ahead and simplify it by just making that a subtraction, and I can't combine anything else, so that will be it. Our last example that we're going to do is y equals cotangent x over 4. So first of all, we hate fractions, so if we can undo a fraction, we absolutely should. So I recognize that this is the same as 1/4 times cotangent of x. And when I have a whole number, or any number actually, in front of a trig function, when I'm taking its derivative, it just stays. So my derivative here is equal to 1/4 times whatever the derivative of cotangent is. And I know that the derivative of cotangent is negative cosecant squared x. So then I simplify this into negative 1/4 cosecant squared x, and that is my derivative. There's a nice little example at the bottom of the notes where we use trig functions in a curve equation and we take the tangent and normal lines. You should really look through that because it is wonderful. Let me know if you have any questions.